So in this stream, we're focusing on what I think is another important skill, which is how to write the paragraph length response. So we'll start off by just talking about what the paragraph length response is and how, like, where you'll see it on the exam, what it might look like, what you have to do. We'll talk about the criteria. So what are the things that you should do in order to get points? And then we'll talk about what are the things you should not do, the things that will lose you points if you go ahead and do those on your paragraph length response. I'll give you a little bit of a kind of step-by-step sort of thing for how to craft your response, just a strategy that you can follow to put together your response. We'll look at a bunch of examples, and then at the end, we'll talk about just some general tips for making your responses as good as they possibly can be. All right, so let's go ahead and jump in. So if we look at what is a paragraph length response. So the paragraph length response is it's one of those short answer types. So if we think about the free response section on the AP Physics exam, you have 3 short answer questions. And then you also have the experimental design question, which we've done a stream about, or a couple of streams, I think, about designing experiments. And you also have the qualitative, quantitative translation question, which I think a lot of what we say in this stream will apply to that one as well, as far as being concise, being clear, making sure you're referencing physics principles and things like that. So you can kind of think of it as these are some tips that'll probably be good there as well. Because it is one of the short answer ones, it's worth 7 points out of the 50 of the free response. And you have a suggested time of 13 minutes to work on each of the short answer questions. So you don't have a lot of time to write this paragraph. And on top of that, the paragraph length response part is usually just a part of the question. So there'll be like an A, B, C type of thing to the question. And then part C will be the paragraph. You'll have answered a couple other things already. It will ask something specific. So it might give you several options. It might, you have a situation and it'll say, what's one thing you can do to make this happen? And you'll get like 3 different choices. And then you have to explain in a paragraph length response why you chose the one that you did, or why your choice will have the desired result. You might be given a quote unquote student's hypothesis, and you'll have to say whether or not it's correct and explain. Sometimes you'll just get a statement that it says is correct, and it's just explain why this is true. So there'll be a specific question though. It's not going to be just like, say something about this topic or a vague general question about a topic. It'll be a very specific thing. Is this true? Or which option is correct, or something like that. And in your response on the AP Physics 1 exam anyway, you can include diagrams or figures and equations. That's not true in the AP Physics 2 exam, which is the other algebra-based one. So if you end up taking both courses, then the following exam on the AP Physics 2, you will not be able to you'll have a paragraph length response, but you won't be able to use equations or draw diagrams in it. So something to keep in mind as well. Okay, so here's some things that you should do in your paragraph length response, or here are some qualities that your paragraph length response should have. And all of these come from this one-page document called the Paragraph Length Response in AP Physics 1 and 2 that the College Board put out in 2015, like right around the time when the exam changed, because I think they knew that writing about physics was going to be tricky. It was going to be something new. And so, they wanted to give students a bit more guidance. And so this document will be linked in the page for this stream, so you'll be able to access it there if you'd like. So it says that your paragraph should be coherent, organized, and sequential. Okay, so you are going to have to think about kind of the writing piece. Like, does it make sense? Does one thing you're saying follow logically from the previous thing that you said? You will need to argue from evidence. you'll need to cite physical principles, and you will need to clearly present your thinking. So you do have to really make sure that you are saying things clearly and that you are backing up what you're saying with physics, with citing a specific principle or equation, or evidence that's given in the problem. So you want to make sure you are, backing your answers up with something that's really concrete. You want to make sure you write a paragraph, not do a derivation and not do a calculation. You are writing. That's part of what they're testing is, can you write clearly about physics, not just, apply algorithms and solve problems and things like that. And it needs to be a moderate length. So you're writing a paragraph, you're not writing a whole page. Okay, they're not going to ask you a question that's going to require a full page of writing. You should be able to explain anything that they're asking in just a few sentences worth of text. Okay, so those are the things that you should do. The things that you should not do are kind of, in a lot of sense, the exact opposite of the things that we just talked about. So if the principles that you are arguing from are not presented in a logical order, okay, so if you just kind of, almost bullet point things, or as we'll see, I think bullet pointing can be a good strategy to start with, but then if you just kind of like write things down in the order that you came up with them, as opposed to making connections, you start at this principle and then that leads to this and then that leads to this. And so it should be an order that makes sense. If you go on lengthy digressions within your argument, okay, starting to think that, if I write a little bit, that's good, but if I write a lot, that's better. That's not the case. You will lose points if you just start tossing in stuff that's not really related, but it's stuff that and you just want to show that you know it. You really got to stick to the actual question. And you will also lose points if you don't write, if you just do mostly equations or diagrams without really linking it together with prose, with actual writing. So make sure that you are writing a paragraph in your paragraph length response. So here's a strategy that you might use, some sequence of steps that you might use to go through the process of writing this response. So first of all, answer the question. Okay, figure out what you think the answer to the question is before you start, kind of tossing out physics principles or writing stuff down or drawing something. Make sure that you're leading towards something. See what your point's going to be before you actually start really thinking about what specifically you want to say. And then make that bulleted list that I kind of mentioned earlier. What are some of the relevant physics principles that are going to make sense here? What are some things that you could, talk about that will help you back up your answer to the question, that will, justify your answer to the questions. And at this point, you can just kind of bullet them really quickly to start and make sure they're relevant. Okay, again, those lengthy digressions or just tossing in things that are like only tangentially related because you think, what if this is the real answer? I want to make sure I get everything in there just in case. Like, no, don't just in case it. Really kind of stick to the point. Think about what sequence you want to put them in. Okay, so what follows logically from what? What do you want to say first? Kind of usually that would be the most basic physics principles. So, something like, one of Newton's laws of motion or something like that would be kind of a basic starting point, and then you would build from there. At this point, you can think about where you might want to toss in a diagram or an equation to clarify something. If you are going to cite a particular equation, yes, you still want to be in prose, but it's probably a good idea to just write in the equation rather than trying to literally write the words of the equation in English out on your page. If you're going to just use the equation, then just write the equation. Don't try to say the equation. And so once you have that information, you should be ready to kind of actually put all that together into a real response and structure it into a paragraph. And then finally, anything you do, you should reread. Of course, if you are pressed for time, then maybe stop after step 5 and come back and reread it if you have time at the end. If your choices are to, make sure your paragraph length response is perfect, or to possibly skip a question, then definitely don't skip a question. It's always better to have answers for everything. And again, this is one of the short answers, so it's not going to be worth as many points as the experimental design or the qualitative, quantitative translation. Okay, let's look at a few examples. There is a link here, so it's kind of weird that it didn't show up. Okay, so this particular question is one from the actual 2015 exam. Here we go. We'll bring these over so we can see them better. And this is, like I said, it's part of one of the short answer questions. So you have 2 identical spheres are released from some device at a time t equals 0 from the same height h. So this looks like one of those ball launcher things that your physics teacher might have, where it drops one straight down and shoots one out horizontally at the same time and from the same height. Sphere A has no initial velocity and it falls straight down. Sphere B is given an initial horizontal velocity v0 and travels this distance d before it hits the ground. But they reach the ground at the same time, even though sphere B travels a further distance to cover before landing. And you are told that air resistance is negligible, as always, pretty much. So there was a part A and a B here that are not shown. In part A, you had to draw free body diagrams of each of them. And in part B, you had to make a graph showing the horizontal velocity for each of them from time 0 to time tf. But in part C is where you had to write the paragraph. So in a clear, coherent paragraph length response, which is the phrasing that they will always use, explain why the spheres reach the ground at the same time, even though they travel different distances, and include references to your answers in part A and B. So again, A was the free body diagram, B was the graph of the horizontal velocity. So unfortunately, it looks like we still don't have any participants in the stream. So at this point, I would love to ask for people to start kind of tossing out suggestions of things, physics principles that might be relevant here. But since we can't really do that, I will just kind of go through that process of answering the question that I laid out earlier. So first of all, the first thing I said to do was to answer the question, and that's not really relevant here because you already have the answer. The spheres reach the ground at the same time, even though they travel different distances. That's the answer. And you're trying to explain why that is true. So we want to start listing principles that might be relevant. And the fact that it says include references to your answers in part A and B, that can be helpful. That's kind of a clue here. So we can, get a sense of what physics principles might be relevant here. So in A, you had to draw a free body diagram. And as soon as they are launched, okay, so you're drawing the free body diagram after they have been launched, they're going to have essentially the same free body diagram, right? It's going to look something like this, where here's the sphere, and then you have weight or FG, or depending on your notation, you might use a different variable, but you're going to have the weight pulling down, and that's it while they're falling in the air. And that's going to be the same for both sphere A and sphere B. So that's principle A. They both, or the first thing that we might want to list. So we could say they both have same force acting on them. So both spheres have the same force acting on them. So that's certainly something that's going to be relevant. Another relevant principle that we would see from looking at the answers to part A and B, they would have different horizontal velocities. both of them are experiencing the same force going downward, but they have different horizontal velocities. Sphere A would have a 0 horizontal velocity while it's falling. Sphere B would have a horizontal velocity, a negative horizontal velocity. I'm sorry, not necessarily negative, but a horizontal velocity as it's falling. So that's another principle that's going to be important to our answer. Another thing we can look at is they fall from the same height, h. So both of them start at the same place and then they land on the ground. And so they're both falling through the same height. And here's where the physics principle would come in. A lot of this is just stuff that's given in the problem, but the real physics principle that's going to be important here is that the time to fall depends only on the vertical acceleration in this case. Okay, so they both have the same force, they have the same mass because they're two identical spheres, and therefore they have the same acceleration. Although, as we know, even if they didn't have the same mass, they would still have the same acceleration due to gravity. But that acceleration determines how long it's going to take them to fall, right? So they have different horizontal velocities as they fall. We could also add, they both start with 0 horizontal velocity. My typing is terrible. So they both start with 0 horizontal velocity, but then they have, wait, no, I'm sorry. They both start with 0 vertical velocity, but they have different horizontal velocities. And they are falling through the same height h, and that time to fall depends on the height h, but also on basically on what's going on in the vertical direction as opposed to the horizontal direction. So at this point, we can kind of put all of this together into a paragraph length response. And so let's see, I'll put this in a different color so we can see that it's kind of the final answer. So the order in which we might want to say this, we're asked why they reach the ground at the same time, even though they travel different distances. So we kind of maybe want to order our response similarly. So talk about the time aspect first, and then talk about the distance aspect. And, kind of think about these principles that we listed and group them together in things that match up. So if we look at things that might be related to each other that we could kind of group together into a sentence, we could talk about the starting conditions, as soon as they fall. So they had 0 vertical velocity to start with. They were at the same height, and they're experiencing the same force. So I think all of that together could kind of be a first sentence. So both spheres start from the same height h with no vertical velocity. And again, looking at starting conditions, we can say they both are affected by the same force, say gravity, and experience the same acceleration. They're kind of bleeding over into the text there. I think it's still readable. Okay, so they both start from the same height with no vertical velocity. They both experience the same force. and the same acceleration due to gravity. And we could say that the time to fall is dependent only on the acceleration in the vertical direction, which is the same for both spheres. So they will hit the ground at the same time. Okay, they're both doing the same thing vertically, so they will hit the ground at the same time because the time is dependent only on what's going on vertically. Now, the second part of the question is asking about even though they travel different distances. So you should include something about that in your response as well. So what we wrote over here that has to do with the distance is really this. They have different horizontal velocities. And so as they're falling, sphere B is going to be traveling in the horizontal direction while it is falling in the vertical direction, where sphere A is not. So you could say that. So sphere B has a horizontal velocity in addition to the vertical motion. I'm just going to say motion here because if I say vertical velocity, it almost makes it sound like an initial vertical velocity, and I don't want to give that impression. So I'm going to say that it has a horizontal velocity in addition to what we already described is going on vertically. So it will travel both horizontally and vertically. Wow. While sphere A travels only vertically. Therefore, sphere B will travel farther. Okay, and I think that covers everything, right? So we've explained what's going on, right? And we've backed it up with physics principles, talking about the fact that they're experiencing the same force, which you would have already said in part A in your free body diagram. We've talked about the time being dependent on the acceleration in the vertical direction, but not horizontal. And these are really the relevant physics principles here. If we look at our next page, this is the scoring guideline for that particular question. And so here's where the points were laid out. So saying that the difference in horizontal motion does not affect the vertical motion of the spheres, you would get a point for that. So I think where we said that the time is dependent only on the vertical would qualify there. For indicating that they start with the same vertical velocity, for indicating that they have the same vertical acceleration, for indicating that falling the same height would take the same time, and then for no incorrect or irrelevant statements. There is a point there just for that. So for not putting in anything that's not true, or that is true but isn't related to the problem. So you really want to make sure that you are, like I said, keeping your answers to the point, because you can actually miss out on getting one of those points, even if you had everything there that is correct, but because you added stuff you didn't need to add. So that's kind of something to keep in mind there. All right, let's look at another example. Okay, so here we have, this one is not from an official AP exam, but it's a similar type of question. So we have an object is held in place by friction on an inclined surface. The angle of inclination is increased very slowly until the object just starts moving. And then if the surface is kept at this angle, does the object speed up, slow down, or move at a constant speed, and why? Okay, so here How this might look at on the exam is you'd probably have sort of checkboxes for speed up, slow down, or move at a constant speed. And you would have to check off which one you think is correct. And then it would say, you know, in a clear, coherent paragraph length response, justify your answer or something like that. And then again, you can use diagrams if you need to. So first of all, this is one where that advice to answer the question is in fact relevant. So thinking about, would the object speed up, slow down, or move at a constant speed? So again, I can't really poll anybody to or ask people to respond in the chat at the moment, but I can tell you what it should be. And here the answer is that the object should speed up. Okay, so you would have to think about the physics of it and get to that point first. You would have to make sure that you are able to, you know, pick which one is going to be correct before you start to obviously write a paragraph to justify that answer. So let's see if we can figure out why that is. So this might be, well, we'll see if we can figure out why that is, and then we'll see how we can craft that into a paragraph length response. So I'm going to start with a diagram here. So here's my inclined surface. And here's my object held in place by friction. So if we are thinking about this in terms of a free body diagram, which is always useful, we could say that we would have the force of gravity here. We would have a normal force coming up this way. And we would have a frictional force going back parallel to the ramp, holding it in place. And the ramp has an angle here of theta, but we are told that this part of the ramp, you know, maybe there's a hinge here or something, and the ramp is going to be lifted and lifted and lifted. Theta is going to get bigger and bigger and bigger until the object just starts moving. And then it's going to stay there. And we want to say, does the object speed up, slow down, or move at a constant speed? For this one, I think move at a constant speed is probably the tempting wrong answer choice. But if we think about what types of friction we have going on here, then we should be able to understand why speed up is actually the correct choice. So while the block is just sitting on the ramp before it starts moving, this friction right here is static friction, right? And so if we think about F equals mu n, then this mu is going to be mu s. It's going to be the coefficient of static friction. And so that is a certain number, you know, a property of whatever the box and the ramp are made of. But once the box starts moving, okay, and so the ramp is going to be increased and increased and increased until that static friction is just overcome. And at that point, the box is moving. So now, instead of this being static friction, now it is kinetic friction because the box is already moving. And kinetic friction, the coefficient of kinetic friction is going to be less than the coefficient of static friction for any pair of surfaces. And so if this is in equilibrium, like if the box just starts moving, if it's in equilibrium at that angle theta, when this is the coefficient of static friction, then once it's the coefficient of kinetic friction, this frictional force is going to be smaller than the component of the gravitational force that's parallel to the ramp. And so this is not going to be in equilibrium anymore. This one is going to be bigger. And so not only is the box going to slide down the ramp, it's going to speed up as it slides down the ramp. It's going to accelerate. Okay, so here is where we need to figure out how to translate all of that into a paragraph length response. So let's think about what our bullet points should be, just as we did before. You know, what things do we want to specifically mention? So I think we want to talk about the difference between static and kinetic friction. Okay, I think that's a point we definitely want to make sure we draw on. We should talk about the forces acting on the object, right? And maybe probably in a AP question, this would be, you know, you would have already had to draw the free body diagram, and then this would be like a part B or a part C onto a given question. So we'll want to talk about difference between static and kinetic friction. That's going to come up in our answer. Certainly we'll want to reference the forces that are acting on the object. And then we might also want to make sure we talk about how the forces change as the ramp is lifted. And then the conditions just before and just after the box slides, or the object. Drew it as a box, so I'm thinking of it in my head as a box. Slides. And so what I mean by that is just before the object slides, it's at rest and we have static friction. And the forces are in equilibrium. It's like just at the point where the, you know, just before it starts to slide, we could say there's going to be this, you know, tiny point where the frictional force and the component of the gravitational force that is parallel to the ramp, they're going to be equal for just like a fraction of a second if we're picturing this ramp going up and up and up and up. So you're going to have that equilibrium point where they are just equal. And then immediately after that, you know, an infinitely small amount of time after that is when the box is going to start to slide. And when you're like just at that point where it just starts to slide, you can say that they are kind of just about equal. It's like it's just been overcome. The static friction has just been overcome. And so that's going to be the point where the box just starts to slide. So that's what I mean by conditions just before. But just after, this force has not changed, but this force has, because now it's kinetic friction instead of static friction. Okay, so how can we kind of put that together into a paragraph length response? So probably the first thing we would want to talk about is the forces acting on the object. You know, again, if we're kind of thinking about a sequential order. So I would say, actually, let's even go ahead and number these. We would probably want to say this, talk about this first. What are the forces acting on it? And then how do those forces change as the ramp is lifted? Talk about those conditions kind of just around that transition point where the box just begins to slide. And then you can talk about how once it starts sliding, now it is not feeling static friction anymore. Now it's feeling kinetic friction, and talk about the differences between those and why that would make the box speed up. Okay, and again, you want to reference what the actual answer is. You want to make sure you actually say that somewhere in your response. So I would start by talking about, like I said, the forces acting on the object, and particularly the forces that are acting parallel to the ramp. I'm going to assume that if this was a real AP question, somewhere in there you would have had to draw a free body diagram. So you'll have that kind of for reference. So we can say that the forces acting on the object parallel to the ramp are the frictional force and I'm going to say the parallel component of the gravitational force. And at this point, you know, like we said, you can use a diagram in your paragraph length response. So if you had not, say, already done that, if you hadn't already drawn a free body diagram, you could put a diagram of that here. So you could kind of give a visual to what you're talking about. So we can say, oops, as the ramp is raised, the parallel component of the gravitational force increases, and you could also, I mean, it is true that the frictional force will decrease here. And I guess that you would probably want to go back and explain why. You could say that as this angle gets bigger, this component of the gravitational force increases where this component of the gravitational force decreases, because this, you know, kind of triangle changes shape here. And you could even, you know, put a diagram in there showing that triangle and explaining why that's true. So, and if this piece of, if the perpendicular, you know, the component of the gravitational force that's perpendicular to the ramp is decreasing, that means that the normal force is also decreasing, and therefore the frictional force is also decreasing. So we didn't list it in our original bullet points, but we could probably spell that out in our answer as well. So as the ramp is raised, the parallel component of the gravitational force increases, and the perpendicular component of the gravitational force, oops, which causes the normal force and therefore the frictional force to decrease. And then I would say F equals mu n. Again, you can reference equations in your paragraph length response. Okay, so this is 1 and 2, forces acting on the object and how those forces change as the ramp is lifted. And now we can talk about the conditions just before and the conditions just after the object starts to slide. So just before the object slides, the frictional force is static frictional force, or static friction, or however you want to kind of phrase that. But after the object is sliding, the frictional force is kinetic. It's one of my most common typos. Is kinetic frictional force. And then lastly, you want to address the difference between static and kinetic friction. So you could say, since the coefficient of kinetic friction is less than the coefficient of static friction, we could say the object will experience a net force acting down the ramp. Okay, because it was in equilibrium just before it started to slide. But after it starts to slide, the frictional force has suddenly decreased. So it will have a net force acting down the ramp. And therefore, it will accelerate. Or speed up. Okay, again, to make sure we're using the phrasing that was asked in the question. Will it speed up, slow down, or move at a constant speed? Okay, so it's going to speed up because now it's experiencing kinetic friction instead of static friction. Okay, so it looks like there are a couple people in the stream. So what we've been doing is we've gone through some, looked at the College Board's guidance for how to write paragraph length responses, kind of a what to do and what not to do sort of thing. And then we also laid out sort of a process for how to write these paragraph length responses. And we're kind of working our way through a few examples. I can see we're got about 12 or so minutes left. So maybe the last 5 minutes, there's a couple more examples here. We might not get to both of them, but the last 5 minutes or so, I can go back to the slides because there's just some tips on the last slide, which will reiterate some of the things we said in the beginning if you weren't here for that. And of course, if anybody has any questions or any comments that they want to make, feel free to put something up in the chat. We can certainly address things, or if you're not sure about something that I said or something that I wrote, then we can go back and address it as well. So feel free to pop those comments in the chat if you'd like. All right, but I do think we have time for one more example. So this one, I'm not sure why all of these keep being outside of the area I'd like them to be in, but that's okay. So this one is from, your physics teacher might have used these as well. They're kind of, Paul Hewitt is kind of kind of a famous person as far as physics goes for writing textbooks and coming up with these really interesting and drawing these cartoons to go with these interesting questions. So here we have two situations, and it says in both cases, an applied force of 100 newtons accelerates the 100 Newton block. So that's block A is the one that's being accelerated in both cases by another 100 Newton force. So in this first situation, that 100 Newton force consists of another block. And in the second one, that 100 Newton force consists of a hand that's pulling downward on the string that goes over the pulley. And the question is, in which case is the acceleration greater? Okay, so if we think about our steps to answering these questions, first thing we want to do, or to writing our paragraph length responses, first thing we want to do is we want to actually answer the question. So in which case is the acceleration greater? Now that we've got some people here in the stream, if there's anybody, if you want to take a guess and put your answer in the chat, do you think the additional weight or the hand, in which case is the acceleration going to be greater for the block that's being pulled across the table? It's going to be this guy. The situation where the hand is pulling, the acceleration is going to be greater. So if we want to try to explain why, the short answer, kind of the non-paragraph length response that we can craft into a paragraph length response, is the fact that in this case, you have 100 Newton force pulling down that is causing this acceleration, but that 100 Newton force, it needs to accelerate both blocks. Okay, this block still has mass, right? If it's 100 newtons, then it's got about what would that be? 10 kilograms of mass. And so it's, you've got 100 Newton force that is having to accelerate, 20 kilograms worth of mass. Where here, this 100 Newton force is somebody's hand. It's an external thing that's not going to be part of the system that needs to be accelerated. And so here you have 100 Newton force that's only accelerating a 10 kilogram mass. And so this one is going to have a greater acceleration. And so if we think about what physics principles we might want to address to be able to answer this. Okay, so we might want to say something about, Newton's second law, right? F equals ma. We would want to put that in our response somewhere. Okay, so that's a basic physics principle that we can cite. We should acknowledge that the net force is the same in both cases. Okay, so that would be another principle we would want to talk about. But the mass to be accelerated is different in each case. Okay, and here it's about 20 kilograms that needs to be accelerated, but here it's only 10. And as far as physics principles we would need to cite, I think that's probably about it. So this one is, maybe a little on the simple side, but I think you can still think about the ideas of how to write a paragraph length response with this particular question. So how would we craft this into a response? So we might say in both cases, a 100 Newton force is applied. I'm going to label these just to make it easier to refer to them. And on the physics exam, they would definitely be given some sort of designation. So since the weights are already called A and B, I'm just going to call this 1 and 2. In case 1, that 100 Newton force is accelerating a 2-block system. Whereas in case 2, that 100 Newton force is accelerating a single block. Since F equals ma, and the force in both cases is the same, but the mass is not. The case with the smaller mass, case 2, will experience a greater acceleration. Okay, and again, that kind of lays it all out. And it's a logical sequence following from one thing to the other. So the force is the same. The mass is different. The mass that is being accelerated by that force. Bringing in a very specific physics principle, probably like the most famous one, Newton's second law, and then relating that principle to the facts that we have stated. F equals ma, the force is the same, but the mass is not. So the case with the smaller mass will experience a greater acceleration. Okay, so there is another example on here, and I'm going to put the link to this bit paper page in the Fiveable page as well. And I believe you should be able to actually edit it. So if you wanted to go in and, you know, I mean, obviously once somebody does it, you'll kind of be able to see, but you can kind of try out doing some stuff on that last example as well. So let me go back to our slides here. Okay, and we can finish up with a few tips in our last few minutes for the paragraph length response. And again, a lot of these are going to be reiterating things that we've already said, but especially if you missed the beginning of the stream, this should be useful information. So the first tip is just please make sure you answer the question, okay? It's really easy to get carried away and like talking about all this background physics, but then never really say what you think the answer to the question is. And it might be tempting to try and do this if you're not sure what the answer to the question is, but pick something, okay? Even if you're not 100% sure if it's the right answer, it's always better to just, you know, stake a claim on one of the answers rather than trying to be wishy-washy and avoid answering it altogether. Link everything you do together with prose, okay? So yes, you can use diagrams, and yes, you can use equations, but don't let those diagrams and equations do all the talking. Make sure that you are writing sentences to kind of link all of that together. More information does not always equal better, okay? Keep your answers concise and clear and relevant and to the point of what you're trying to say. Make sure you put your information in a logical sequence, you know, structure it in a way that makes sense. So here's where that idea of listing out the physics information you want to include and then kind of numbering it to say, okay, what makes sense to go first? What makes sense to go next? You know, putting all that in an order will help your answer flow logically from one step to the next. And then lastly, state things clearly and concisely. You want to be specific enough, like for example, you know, try to avoid using the word it, you know, like, you know, saying it increases or something like that. You want to make sure you're being really clear, you know, the speed increases or, you know, whatever it happens to be. So don't be vague, but at the same time, you don't need to use the floweriest language you can and make it, you know, you're not trying to imitate a physics textbook. You know, you're a student. You should write like a student, but also make sure that you are really answering the question and that you're not writing anything that's not actually correct. Yeah, and I think that's about it for this stream and for our tips. We've got, I don't know, like 30 seconds left. So if anybody's got any last minute questions they wanted to offer. But if not, I would remind you to follow Think Fiveable on all these different social media platforms to get all the information about streams that are coming up and about AP stuff in general. There's a lot of really good streams, you know, in many, many other subjects, not just physics. So you can, if you're taking more than one, it's definitely something you want to check out to see what's going on there. All right, and thank you for being here. And yeah, that's about it. Have a good week at school.